For years, the C-130 has played the part of its name, Hercules, and always in a helpful role. It is used to haul cargo, troops or passengers, and litter patients. It is an indispensable element of TAC airstrike deployment and is a launch platform for Firebee drones. It performs air rescue pickups from land or sea. And can be used as a tanker for HH-3E helicopters. It recovers capsules from Discoverer satellites, performs photo mapping missions, and tracks storms for the Weather Service. It has been used to support operations in the Antarctic and is included in the inventory of the Navy, the Coast Guard, and 13 foreign countries. Here at Wright-Patterson Air Force Base, under the management of the Deputy for Limited War, the Deputy for Flight Test changed its costume again to play a different part, the role of a night-prowling attack aircraft called Gunship II. With its electronic eyes, it seeks for and finds its own enemy targets, then smashes them with a devastating rain of firepower from 8 side-firing Gatling-type guns at a rate of 34,000 rounds per minute. But before this AC-130 prototype could be sent to Southeast Asia, months of modification and testing were required. One of these was the stuffing of fuel tanks with inerting polyurethane foam for the suppression of explosion in the event of an incendiary hit. It was very important that each piece of foam be cut to fit snugly and exactly around pipes and tubing and into all corners and crevices to eliminate any voids where fuel could accumulate. An aluminum booth was also built for the sensor operators and for installation in the center section of the aircraft. The booth was completely insulated with about 2 inches of Celotex, and then a layer of sound-deadening acoustic tile was also applied on the inside to reduce aircraft noise about 45 decibels to provide greater operator concentration on imagery and instruments. To provide even greater safety, its floor was armor-plated. Many items of equipment were removed from the interior of the aircraft for the addition of 4 of these 20-millimeter side-firing Gatling-type cannon on their special mounts. 2 were mounted forward and 2 aft. Mounting the cannons presented several problems. While they could be bore-sighted as to azimuth and elevation, they had to be anchored in a fixed position. These 2 at the rear posed a special problem because 2 7.62-millimeter guns were mounted immediately above them. The forward cannons were mounted just behind the pilot's compartment. This was an easier installation because the 2 miniguns were mounted above and aft of the cannons. Nevertheless, all 8 guns had to be wired into the computerized fire control system so they could be fired in any combination or rotation the pilot wanted. Some idea of the tight fit of the rear guns is shown here as engineers closely examine the clearances that have been allowed for their operation and maintenance. The installation of the forward miniguns was comparatively simple and allowed ample room for the tubes that capture the spent shell casings and for final inspection of the installation of both the guns and their wiring. The sensor operator's booth was then installed. Several censoring devices and other electronic equipment will be placed in it. The loose curtain around it is ballistic felt for further protection from flak. This is a better perspective of the forward 20s with miniguns above and aft of them, the aft 20s with miniguns directly over them, and the side-looking installation of a Beaumark A radar. This first radar installation proved unsatisfactory and was changed later. This view of the 2 rear 20-millimeter cannons next to the radar shows how compact all modifications had to be. The 2 forward 20-millimeter cannon have been installed at an extremely low angle of depression, but this was not their permanent position. A view forward shows the 7.62 miniguns mounted in their firing position. Here again, compactness of installation is demonstrated by the closeness of the forward miniguns over the wheel well, and the size of the apertures in the fuselage, which are just large enough. With all major modifications to the aircraft completed, a last walk-around check and inspection is made before takeoff for Eglin Air Force Base for first flight test and static test firing. For the flight to Eglin, the guns were stored inboard and the gun ports closed. At Eglin, the aircraft was made ready for its first static test firing of the 20mm cannons on their specially fabricated gun mounts. This was the first deficiency encountered in the mounting of the guns. They weigh 350 pounds and had to be manually worked into their cradles affixed to the base plate. A third man was needed on the inside to help and to set the gun at the desired elevation. After all 4 guns were placed, anchored, and sighted, the belts of ammunition were loaded. The aircraft normally carried 6,000 rounds of 20mm high-explosive incendiaries and fires at a rate of 2,500 rounds per minute. The first static firing showed a deficiency in the mounts that allowed the guns to whip. A close-up shows the extent of whipping that brought about a pattern of widely scattered hits. Even though all guns showed the same whipping, an airborne firing test was made to learn what the results would be. The 4 squares are the target on the pilot's fixed reticle. The rear guns fire, miss widely, and aircraft vibration is noticeable. Then the forward pair of 20mm cannons were fired. And this air-to-sea view shows how far off target they were. The second and third bursts were also wide. Then all 8 guns were used. The miniguns were closest, some being on target, but they generally hit in a widely scattered pattern. Correction of these conditions was a prerequisite, so the aircraft was flown back to Wright-Patterson for further modification and the addition of other items to make it ready as a night prowling aircraft for combat duty in Southeast Asia. The change began with the addition of camouflage in the colors used in jungle country. Apertures were cut out for the addition of several censoring devices. The tedious and intricate job of wiring all guns, communications, and electronic equipment was accomplished. The forward-looking radar on the nose was checked and inspected to ensure its accurate and efficient operation. Heavy armor plate was cut to size for addition to the aircraft's flooring sections to take and absorb direct hits from small arms ground fire and heavy flak particles. The Beaumark A radar was further modified to work with ground beacons. This makes possible firing at targets offset from ground beacons, thereby bringing all-weather support to friends on the ground. A new direct view night observation device called NOD was also installed. In effect, NOD is a nighttime telescope. With only the stars as a light source, its image intensifier tube behind the lens will magnify the available light by a factor of 1,000,000, thereby making targets clearly visible. Another of the gunship's electronic eyes that was installed is this side-looking infrared system. The mirrors in the scanner head spin at about 7,900 RPMs and are part of the system that detects minute differences in temperature, as little as 1/2 degree centigrade, and turns these temperature differences into visible pictures, even in total darkness. An onboard illuminator is another important element used to search for and find targets at night. Its 20-kilowatt xenon lamp produces 700,000 lumens and can illuminate targets a mile away, and its infrared filter can be used covertly for illumination when it is too dark for NOD to see. The illuminator is used on the aft end of the aircraft, about 4 feet beyond the ramp. It can be pointed fore and aft of the aircraft and also from side to side. After serving its purpose outboard, It can be swung inboard on its swivel joint and stored out of the way for future use when needed. The aircraft was also equipped with a newly designed UHF radio beacon system that allows the pilot of the aircraft to read direction and slant range to a ground-operated transceiver. And so the venerable C-130, which has been worked over, facelifted, officially designated as an AC-130 and Gunship II, has Vulcan Special painted on its side, and is affectionately called Big Spooky, takes off once more for Eglin and in-flight testing. At Eglin, it is taxied into position for static test firing before airborne testing of guns and electronics. All guns have been set, loaded, and made ready for the first test of the stiffened gun mounts and beefed-up base plates. The pilot checks to be sure everything is clear, then fires. First the rear, then the front. The gun whip problem has been solved, and the guns hold steady. Then all guns go. There is still no whipping, and the pattern is effectively clustered. The guns were then aimed at nearby targets, and another burst was fired. Both targets were destroyed. Big Spooky was now ready for in-flight testing. First flight testing at Eglin was done by VFR to test each piece of sensor equipment and its input to the computerized fire control system, and also to test the synchronization of the guns with the same system and sensor equipment. Now let's watch each operator using his sensor. The nod operator scans for the target, finds it, and makes the information known so it can be fed to the fire control computer. The computer operator sets in the flight wind correction necessary for firing accuracy, and the infrared operator scans with his sensor until he too is bearing on the target. A stick control is used to direct the infrared scanner head in a search for the target. When it is found, the information automatically goes to the computer. The fire control computer gives the pilot guidance, and he flies his aircraft and maneuvers it until the needles are centered. When they are centered, he knows he's a beam of the target. The pilot then rolls the aircraft into a 30-degree bank, orders the guns he wants from the master gunner, then transfers his attention to the fixed reticle. He maneuvers to superimpose the computer-generated moving reticle over the fixed reticle to pinpoint the target. When pinpointed, he presses a button on the control column, and the guns he has ordered shoot. The cannons, the sensors, the computerized fire control, and the pilot's side window gun sight all prove out, as the target is smothered, even though it is a mile away. Then the miniguns go, followed by the 20-millimeter cannons. The orange bursts are direct incendiary hits on a target only 24 feet square. Other night mission equipment was also tested, including these Mark 24 flares in an LAU-74A launcher. The flares fall to preset altitudes, then pop open, producing about 30 million candle power of illumination as they float slowly down. In the event of a hit on the quick jettison launcher, the smoke clearing capability of the aircraft was tested with a smoke pot on the ramp. Smoke clearing was rapid and complete. The pilot calls for the xenon lamp to illuminate the target for night test firing. The black cone in the center is on target. All 8 guns were used, and all were on target. The guns, the sensors, and the computerized fire control all proved to be satisfactory for combat. With the result, the prototype AC-130 was deployed to Southeast Asia on 15 September, where it flew more than 70 combat missions in Vietnam and Laos. In December, it was brought back for rework, and then redeployed to Vietnam in February. Primarily, its missions were night attacks, and the same procedures used successfully at Eglin Air Force Base were employed. Normally, Big Spooky carried 6,000 rounds of 20 millimeter and 32,000 rounds of 7.62 ammunition. Over the Ho Chi Minh Trail, it was shooting nearly 8 tons of ammunition per night. In just 1 week of night interdiction missions in Laos, Big Spooky proved the devastating effect of its accurate and smothering firepower. On 7 sorties along the Ho Chi Minh Trail, the enemy's main avenue of supply and communications, it destroyed 23 trucks, damaged 8 more, set off 22 secondary fires and explosions, and knocked out 3 automatic weapons positions. The AC-130 has clearly demonstrated under combat conditions that a new dimension has been reached in night attack operational capability, and its impact is sure to be felt in future Air Force systems and tactics.